The Rosetta mission explored Comet 67P, Churyumov-Gerasimenko. It is considered one of the most ambitious missions of the European Space Agency, ESA. NASA is not the only organization conducting missions to explore worlds beyond Earth. The Rosetta mission stands as the clearest testament to the capabilities of the European Space Agency, ESA. This incident allows us to observe for the first time a shooting star at the edge of the LIGON system, which is a visitor from the Kuiper belt, or a more distant belt, consisting of drifting stars and asteroids located beyond Neptune's orbit. This is also a groundbreaking mission, as it involves landing a probe on the surface and directly analyzing materials found on the comet. Its discoveries are vast and impressive, offering us profound insights into the farthest reaches of the solar system, how it formed and, more importantly, the answer to why comets once contributed to the creation of life on Earth. However, did everything go as planned? What happened during this mission, and what discoveries left the scientific community utterly astonished? 67P Churyumov-Gerasimenko, commonly shortened to Chury, is currently a Jupiter family comet. This means its orbit is no longer as far from Jupiter as it once was. Although it once belonged to the Kuiper belt, meaning it originated from the region of space beyond Neptune's orbit. The Rosetta mission was launched on March 2, 2004, aboard an Ariane 5 rocket by the European Space Agency, ESA. Initially, the plan was scheduled for launch in 2003 with a completely different objective. But the Ariane 5 rocket program suffered a severe failure, leading to the mission's suspension. The initial goal was not achieved, so a new target must be chosen. ESA has decided to aim for Comet Chury due to its ideal orbit. After entering space, the Rosetta spacecraft endured a challenging 7-year journey to reach its destination. It needs to utilize the gravitational pull of several planets to approach the star Chury. In 2005, the Rosetta spacecraft flew past Earth, and then in 2007, it passed by Mars. This flight over Mars is quite risky due to the close approach of just 250 kilometers above the red planet's surface. Additionally, during the 15-minute flight, the spacecraft will be completely engulfed by Mars' shadow. Since the nest operates on solar power, it has to switch to standby mode. The components of the Rosetta module must be warmed using an electric repair device directly on the module to prevent damage from the harsh conditions of outer space. However, its battery isn't designed to run continuously for that long. The Rosetta team's energy has dropped to a dangerous level, and if they are completely depleted, they will never be able to recover on their own. Thus, the mission control team could only wait helplessly in hope. They call this the billion-dollar gamble. Fortunately, the flyby of Mars went smoothly, and the mission continues as planned. Even they managed to snap a few photos of Mars during the event. In 2007, the spacecraft Rosetta flew past Earth again at a distance of 5,700 kilometers. Interestingly, during this pass by Earth, the object was detected by ground-based telescopes and initially mistaken for a near-Earth asteroid. As a result, it was listed in the Catalina Sky Survey as an asteroid at risk of hitting Earth. It wasn't until several days later that people realized the mistake. Rosetta returned to its orbit with gradually increasing altitude, having passed the asteroid 2867 Steins. A small asteroid, 5 kilometers in length, lies within the asteroid belt beyond the orbit of Mars. Here are some photos that have been taken. In 2009, the Rosetta spacecraft completed its final flyby of Earth. The final flight gave it the momentum to approach Comet Chury. In the final leg of its journey in 2010, the spacecraft flew past another asteroid named 21 Lutetia, which has a diameter of up to 100 kilometers. The ship then switched to reserve status and remained so until 2014. When first approaching the 4.5 kilometers wide Comet Chury's thrusters, they successfully adjusted the Rosetta. As they drew closer, those wondrous images suddenly appeared, leaving everyone utterly astonished. This comet resembles a true binary system up close, with all kinds of rugged terrain, jagged ridges, sharp surfaces, sheer cliffs, deep valleys, and intricate fissures. That was a spectacular sight, well worth admiring, and far more fascinating than we had ever imagined. However, when looking at these images, the mission team was also extremely frustrated, unsure of how to land safely in this area. The Rosetta mission consists of two main components: the Rosetta orbiter and a smaller lander probe named Philae. The mission control team plans to land the Philae probe on the comet's surface to conduct a detailed analysis of its composition using multiple scientific instruments. If the landing fails, we will completely lose the chance to gather scientific data on this extraordinary object. Therefore, the Rosetta spacecraft's first task upon entering orbit was to survey the rugged surface of Comet Chury to determine the optimal landing site. Besides the non-spherical shape of the comet, another factor to note is the amount of gas escaping at each specific location. Some regions on the comet are highly active, releasing vast amounts of water into space, especially as it approaches the Sun. The amount of water escaping into space is precisely what creates the comet's distinctive features, including its glowing halo and the unique tail that no other celestial body possesses. Landing in an area with a gas leak was deemed too hazardous for the health of the Philae landing team. Therefore, they chose a location with less activity. On November 12, 2014, the Philae lander detached from the mothership Rosetta and began its descent to the comet. The Philae is equipped with two harpoon-like hooks that can be fired into surfaces, securing the device and preventing it from bouncing during operation. Controlling the mission as the Philae spacecraft landed filled my heart with excitement and anticipation. But then, the ship also landed safely on the ground. The device sent a landing signal to the control center to report the successful completion of the mission. However, there was a crucial detail that the mission control team overlooked. The iron hooks on the bridge still haven't been sold, even though the survey bridge has been lowered. It was immediately ejected from the comet's surface. Here are the natural English translations for the given Vietnamese text. But at that moment, the Philae ship was truly adrift in space. A serious and prolonged misunderstanding occurred, lasting until they realized that the process had not properly ended and was still ongoing. Luckily, this hit only reached a speed of 38 centimeters per second. It means it only rises 1 kilometer above the surface before returning to its original position. Within 2 hours, the ball bounced 3 times before coming to rest. What a shame it landed far from the intended drop point and came to rest here, a place usually shrouded in the sun's eternal shadow. This means the device will quickly run out of battery because the solar panels aren't capturing enough light. On the other hand, the mission team felt extremely fortunate as the spacecraft appeared to have landed in the correct orientation. Therefore, it is still possible to collect at least some useful scientific data. But they also had to quickly gather as much scientific data as possible before the battery ran out. Their estimated 5-month project was unexpectedly cut short to less than 60 hours. By November 14, the Philae lander had exhausted its power and ceased operations. But the surprising thing was in June 2015, when it was exposed to more sunlight due to moving closer in its orbit. The Philae lander has successfully connected and transmitted signals back to the mothership. Despite the interrupted signal, the lander still managed to complete one final science experiment. This is the concert radar test, and it has returned the measured results. However, over time, this bulge becomes more active as it approaches the sun. Initially, it emitted only 500 grams of water and dust per second, but as of now, the emission has increased to 300 kilograms per second. This means that to ensure Rosetta's safety, the spacecraft must follow an increasingly expanding orbit moving farther away. On July 9, the Philae spacecraft sent its final signal before permanently shutting down. It wasn't until September that the research team finally pinpointed the final resting place of the Philae lander. You can see the bunny's feet right here. Determining the landing position of the beehive is crucial, as it enhances the accuracy of the collected scientific data. So, what did the Philae probe discover when it landed on the comet's surface? Setting foot on this star was already a great success for the mission planners. To date, no other object in the solar system that has been thoroughly studied bears such a striking resemblance to Comet Chury in shape. The lake is approximately 5 kilometers long at its widest point, with 2 lobes connected by a narrow strip of land in the middle. This was already quite unusual, and also very rugged, unlike most of the asteroids we've ever known. During the mission, it was observed that the surface of this star is highly variable. Upon closely examining the neck area connecting the two lobes, it becomes evident that this region is subject to mechanical stress. When observing these rocks, one can notice the fault lines running through them. The fault lines also become clearly visible when viewed from a different angle. Scientists used a model based on the fault lines around the neck region to determine that these cracks penetrate deep into the protruding star, reaching depths of 500 meters below the surface. As the star rotates around its axis, the two lobes appear to stretch apart, causing the neck region to become increasingly thinner. People have observed 10-meter-tall giant rocks being displaced due to mechanical stress, along with surface fluctuations. Sometimes, due to weak gravity, frost flowers can grow as tall as 100 meters. This also shows that their structure is quite brittle and fragile. Here's a lesser-known fact about the new star before this mission. Like fault lines, its structural layers are also observable, revealing that during its formation, this star gradually evolved over time. However, despite having a certain crispness, the surface of the salt flat is much harder than initially expected. Scientists predicted that the surface where the Philae lander initially touched down would be soft and porous, resembling dirty snow, but the reality turned out to be completely different. As it approached the comet's surface for direct interaction, it realized the final landing site was actually a block of hard ice covered by a thin layer of dust, previously mistaken for solid ground. The crew of the Philae ship made efforts to collect soil samples, but due to the vessel's unfavorable position, they were unable to lower the drill bit to the surface. However, they could still determine the outcome by analyzing the debris scattered onto the ship when it was ejected. Among the surface materials surveyed, the study identified 16 compounds with varying mechanical effects. Notably, 4 of these compounds had never been previously detected on protostars. Although it's uncertain whether life must necessarily be based on organic compounds, in reality, all life we know of is composed of these compounds. Although the Philae lander did not collect much surface data, the Rosetta spacecraft was still able to retrieve some comet samples by capturing icy dust particles ejected from the comet itself into space. One of the most striking images captured by the Rosetta spacecraft is a video showing cosmic dust and debris shooting out in all directions, with stars faintly drifting in the distant background. All the particles are observable because the Rosetta spacecraft is heading toward the dark side of the comet. This allows the camera to increase exposure, thereby capturing detailed and fascinating images. Throughout its mission, the Rosetta spacecraft collected approximately 31,000 dust particles. Notably, their composition remained unchanged, even as the comet became more active. This suggests that the entire comet nucleus is capable of maintaining stability throughout the process. The dust particles consist of a complex mixture of organic materials, mixed with sodium, magnesium, aluminum, silicon, calcium, and iron. However, the difference between this material and the asteroid material lies in the fact that it contains a large amount of hetero-element bonded with oxygen. One hypothesis suggests that asteroids were heated for much longer than planetesimals because they were located closer to the Sun. This once again removes the heterosexual element from their composition. However, for most of their lifespan, centaurs have been pushed away from the inner regions of the solar system. This means these dust particles are pristine relics from the early days of the solar system's formation, possibly even remnants of the molecular cloud where the Sun was born. Oxygen is a surprising discovery due to its high reactivity. When exposed to hydrogen, it often bonds to form water molecules. The Philae probe has detected boron molecules and heterocyclic compounds in the fragile atmosphere of the protostar. The dust particles you see here are all very tiny. The largest one collected is only 2 millimeters in diameter. Interestingly, it's these tiny particles that light up the sky during meteor showers on Earth. Nevertheless, these perspectives have provided us with profound insights into the material origins that formed the solar system. Therefore, we can understand where our solar system originated from. Saturn has a very dark surface, reflecting only about 3 to 4% of the sunlight that reaches it. What you'd hardly expect from something so cold and icy. However, in reality, the amount of ice in direct contact with the planet's surface is not substantial. Most neutron stars are covered by a layer of dust containing complex compounds, darker than even asphalt. The colored sections represent areas where water has leaked out. You can see, this is not a significant percentage of sunspots. Instead of being reflected, the light is absorbed, causing the volatile material layer beneath the dust to heat up. The passage causes the phenomenon of water vapor and volatile organic compounds escaping. At the same time, it also caused the tiny dust particles collected by the Rosetta spacecraft in space to be scattered. Because these materials are ejected outward at an extremely high escape velocity, they trail behind the comet and form its tail. Why do comets have two tails? The dust tail is the part that follows the comet's trajectory. The fox's tail gleams brilliantly when sunlight reflects off it. The remaining tail contains volatile materials, water, and bond dioxides escaping from the rising star. This tail aligns with the direction of the solar wind, and these particles are illuminated through the process of ionization and interaction with charged particles from the sun. On Earth, you can often observe shooting stars with the naked eye. But if a protostar releases enough material, it may become visible. ESA carried out the Rosetta mission for another important reason. This aims to check whether the water on comets is the origin of Earth's water. One hypothesis suggests that from its earliest stages of formation, Earth was intensely bombarded by meteorites while carrying out this mission. When the solar system was still in utter chaos. Most comets are primarily composed of ice and water. These elements may have delivered to Earth's surface the kind of water we use today. But in reality, according to the findings from the Philae lander, that did not happen at all. Scientists identified this by analyzing the ratio of deuterium to hydrogen in water vapor. Clearly different from Earth, deuterium is an isotope of hetero supplemented with neutronium. The ratio between deuterium and hetero in water is the key factor in determining an object's position in the solar system. This is the size of Earth, and this is the size of the dwarf star Turi. Currently, only 2 stars have had their water vapor directly measured to detect deuterium. Strengths and Hanley, and neither of these stars was the source of Earth's water. Instead, this data provides greater value to models that assume asteroids are the source of Earth's water supply. Although their water content is typically very low. Perhaps there were once many oceans here billions of years ago. Perhaps we've simply never seen so much water before. The volatile compounds on the asteroids had all burned away. No matter the circumstances, it seems Earth has gone through a challenging formation period. The Rosetta and Philae clusters are also equipped to detect whether the emerging star has a magnetic field. The result is they did not detect a magnetic field on the star. The Rosetta pod completed its mission by plunging into the surface of the forming star. When the rising star moves closer toward the sun, there is no guarantee that it will have enough energy to power its reactors. Therefore, to achieve the highest scientific research efficiency, the mission control team assigned it to execute a controlled dive toward the emerging star. On the downward journey, it has captured many photos that you can look back on over the past period. Delivers a sharper perspective on the standout star, until it sent its final signal back to Earth. The Rosetta mission has expanded our understanding of how the solar system formed and evolved, and has provided data, applied, and will open up many new discoveries. Hope there will be more exciting missions like this in the future. The exploration of space is becoming increasingly fascinating and exciting.